Solving systems by elimination. Remember that we have solved systems by graphing. We graph the two lines, we name where they intersect. That point where they intersect is a solution to both equations. If I plug that point into both equations, it makes them both true. The other technique we use was substitution, where I isolate a variable, get a variable by itself, I substitute in the other equation and solve, and then I plug that answer I get back in to get the other value of the ordered pair. We're always creating an ordered pair, an X and a Y, and it's always where two lines intersect every single time, no matter how we find that point. Our last technique we're going to learn is elimination. It's called elimination because what we do is we line up the two equations and we make a pair of opposites, and we will add the two equations, eliminating one of the variables. You'll see that in just a moment. So let's go over the steps again. First thing, you want your equations in standard form. Standard form is ax plus by equals c. Then we're going to take one of those two equations and multiply. Sometimes you have to use both equations, but usually just one. Multiply by a number that creates a pair of opposites. We want either the x's to be opposites or the y's to be opposites. And the reason we want opposites is we can then add the two equations. And what do opposites add to? 0. That makes them gone. They're eliminated. So we'll add the two equations once we have the pair of opposites, and we'll solve. And we'll get one of those answers, one of the values, one of the coordinates of the ordered pair, and we'll plug that back in one of the original equations and find the other value, creating an ordered pair. And again, it's where two lines intersect. It's the point that makes both equations true. Let's take a look at an example. Looking at the x's in this equation, if I wanted to make a pair of opposites out of the x's, I'd need to find the common multiple of 2 and 3. It's the same thing as the common denominator. Think of multiples. 2, 4, 6, 8, 10, 12, 14, 16, 18. That's multiples of 2. Multiples of 3. 3, 6, 9, 12, 15, 18. The common multiple is the smallest number that both 2 and 3 divide into evenly. 2, 4, 6, 3, 6. They both divide evenly into 6. So if I were to use the x's, I'd want to make a pair of opposites. I could multiply the top one by 3, because 3 times 2 makes 6. That would be 6x. The bottom one, I'd want to make negative 6, because I'm going to make a pair of opposites. 3 times 2 is 6. 3 times negative 2 would be negative 6. This would make a pair of opposites right here. Now, this may not make any sense to you yet. This isn't the way I do the question. I would use the y's. The way I did it here, I actually had to do both equations. And that isn't necessary. Take a look at the y's. See how the bottom y is 8, negative 8? The top y is negative 2. What I want is to make a pair of opposites. If this one is negative 8, I want to make the top one positive 8. What do I multiply negative 2 by to make the opposite of negative 8? In other words, I want to make negative 2 positive 8. Negative 2 times negative 4 is positive 8. So I'm going to multiply by negative 4. Now this may not make sense yet, just hang in there. I'm going to take everything in this equation by negative 4. Negative 4 times 2x is negative 8x. Negative 4 times negative 2 is positive 8y. And negative 4 times 8 is negative 32. Notice I also did the 8. You do every term by whatever number you're multiplying by. Now rewrite the bottom equation, 3x minus 8y equals 27. We've created this pair of opposites right here. And if I add straight up and down, 8y and negative 8y make 0. So let's add. Negative 8 plus 3 is negative 5. x. Positive 8y and negative 8y make 0, so I can forget about that. Equals negative 32 plus 27 is negative 5. And now I can solve for x. Just divide both sides by negative 5. And I see that x equals 1. Once I know one of the coordinates of the ordered pair, I can take that coordinate and plug it in one of the equations. I'm going to use that original equation, which was 2x minus 2y equals 8. And I'll plug in that 1. 2 times 1 minus 2y equals 8. Well, 2 times 1 is 2. 2 minus 2y equals 8. Subtract 2 from each side. Negative 2y equals 6. Divide both sides by negative 2, and I can see that y equals negative 3. So the coordinate where the two lines would have intersected if I graphed them would be the ordered pair x is 1, y is negative 3. We're going to do a bunch of examples here in just a moment. It takes practice, but you'll get the hang of it. Just watch. The first thing you need to realize, when you use elimination, your equations need to be in standard form. You need to have the variables on one side and the number on the other. The variables on one side, the number on the other. You've got to line up the x's and line up the y's because remember, you're going to add them and eliminate one of those variables. This one won't work because I've got a variable by itself. That's a substitution type question. This is the one you want for elimination. You need your equations in standard form. These first equations are set up for you. They're ready to go. I've already got your opposites. Let me rewrite the equation. 4x minus 3y equals 18. 6x plus 3y equals negative 18. Notice that you have the pair of opposites that you need. That means you can add the two equations. I get 10x here. 6 and 4 make 10. That makes 0. Well, look at that. 18 and negative 18 make 0. Now, this isn't no solution. If you divide by 10, 0 divided by 10 is 0. Take that value and plug it in one of the equations. How about the top one? 4x minus 3y equals 18. I'm going to plug in x is 0. 4 times 0 minus 3y equals 18. That's negative 3y equals 18. Now I can divide by negative 3 and see that y is negative 6. So the ordered pair where the two lines would intersect, the ordered pair that would make both equations true is 0 for x, negative 6 for y. Always alphabetical, x, comma, y. Question 3 is already set up for you. You have your pair of opposites. So we'll put that line there and add straight up and straight down. 2x and negative 2x make 0. They're eliminated. 5y and 7y make 12y. 54 and 42 make 96. Now I can divide by 12 to find y, and y will equal 8. Now that I've got 8, you can use either equation. It makes no difference. I'm going to use the top one again. 2x plus 5y equals 42. I'm going to plug in that 8. 2 times x plus 5 times 8 equals 42. That's 2x plus 40 equals 42. Let's take a 40 off each side. We're going to get the x by itself. 2x equals 2. And divide by 2, and x would be 1. The ordered pair that makes both equations true is 1, 8. Question 4 is also ready to go. You just need a pair of opposites. It can be the x's or it can be the y's. The x's are opposites already. Negative 6x and 6x make 0. Negative 8y and positive 2i, when I add them, make negative 6y. I'm adding everywhere. You have to do the same thing everywhere. 44 and negative 20 add to 24. I'll divide by negative 6, and y will be negative 4. I'm going to use the second equation this time. Doesn't matter which one you use. 6x plus 2y equals negative 20. 6x plus 2 times, I'm going to plug in that negative 4 equals negative 20. 6x plus negative 8 equals negative 20. Now I can add 8 to both sides. So 6x equals negative 12 and divide by 6. And I get that x equals negative 2. So the ordered pair in alphabetical order is negative 2, negative 4. Question 7 is different because I don't already have a pair of opposites. Remember that you can use either equation, the x or the y. Choose the one that looks the easiest. Let me rewrite these equations. Negative 6x minus 5y equals negative 13, and 2x plus 20y equals 96. You need to find the least common multiple, the smallest number that both numbers divide in. For 6 and 2, the smallest number that both of those divide into is 6. Don't think greatest common factor. Think least common multiple. 6, 12, 18, 24, 2, 4, 6, 8, 10, 12. The smallest number they both divide into evenly is 6. Now, if you use 12, it would work. We just have bigger numbers. Look at the 5 and the 20. The smallest number that they both divide into is 20. So you could either use 6 or you could use 20 if you do the x's or the y's. Let's use the x's because the numbers are smaller. All I need to do then is manipulate the second equation. I've got negative 6 right here. I want this to be positive 6 so that I have that pair of opposites I need to add and eliminate x. What do I multiply 2 by to make it positive 6, the opposite of negative 6? Well, that would be 3. So I'm going to take this whole equation by 3. I'll rewrite the top. Negative 6x minus 5y equals negative 13. And the bottom equation, I'll multiply everything by 3. 3 times 2x is 6x. 3 times 20y is 60y. And 3 times 96 is 288. Now, I'll add. The x's are eliminated. Negative 5y and positive 60y make 55y. 288 plus negative 13 is 275. Now let's divide by 55 to get y by itself. 275 divided by 55 is 5. So y equals 5. Now that I know y, I can plug that in one of the equations. I'm going to use the top one. Negative 6x minus 5y equals negative 13. Negative 6x minus 5 times 5 equals negative 13. That's negative 6x minus 25 equals negative 13. Let's add 25 to both sides. We're going to get the x by itself. Negative 6x equals 12. Negative 13 plus 25 is 12. Let's divide by negative 6 to get x by itself, and x would be negative 2. The ordered pair where both lines would intersect if we graph them would be negative 2 for x, always alphabetical, x first, and 5 for y. In question 8, we don't have a pair of opposites, so we're going to need to make one. We can do the x's. What's the common multiple of 1 and 3? What's the smallest number that both divide into evenly? Remember, the smallest number that 3 divides into is 3 evenly. Both of these would divide into 3, so I could take the top equation and make this positive 3. I want that pair of opposites. Or I could do the y's. The smallest number that 3 and 4 divide into is 12. Notice that 3 times 4 is 12. That will always give you a common multiple, maybe not the smallest though, if you multiply the two numbers. Let's do the x's because again the numbers are smaller. This is negative 3. I want the negative 1 here to be positive 3. What do I multiply negative 1 by to make it the opposite, positive 3? The opposite of negative 3. Well, that'd be negative 3. Let's take the top equation and multiply everything in the equation. Don't forget the 7 by negative 3. Negative 3 times negative 1x is 3x. Negative 3 times 3y is negative 9y, and I could have written minus 9y. That would have been good. Negative 3 times negative 7 is positive 21. Careful with your signs here. It'd be so easy to make a mistake. I'll rewrite the bottom equation. The x's are eliminated. When you add them, you get 0. We're going to add everywhere. You get negative 5y equals 10. Divide both sides by negative 5, and y will equal negative 2. Take your pick and use the top equation. Negative 1x plus 3y equals negative 7. That's negative 1x plus 3 times negative 2 equals negative 7. I plugged in negative 2 for y. Negative 1x minus 6 equals negative 7. Let's add 6 to both sides. Negative 1x equals negative 1. I'll divide both sides by negative 1 to get x by itself, and x is positive 1. So the solution to this system of equations is x is 1, y is negative 2. In question 9, I need to create that pair of opposites. For the x's, both 4 and 2 divide evenly into 4. 4 is the smallest, they both divide into evenly. Smallest number that 4 divides into is 4. Don't think 2. The smallest number that 4 and 2 divide into evenly is 4. 5 and 20, the smallest number that 5 and 20 divide into evenly is 20. Remember, the smallest number that 20 divides into is 20. Goes in once. So let's use the x's again because the numbers are smaller. The top one is negative 4. I want to make the negative 2 positive 4. What do I multiply negative 2 by to make positive 4, the opposite of negative 4? That'd be negative 2. I'm going to rewrite that top equation. Negative 4x plus 5y equals 22. And I'm going to multiply everything in this equation by negative 2. 4x minus 40y equals negative. When I multiply 46 by negative 2, I get negative 92. I'll add the two equations. These are eliminated. They're gone. 5 and negative 40 make negative 35y. 22 and negative 92 add to negative 70. Divide both sides by negative 35. And y will equal 2. Let's use this top equation. Either one works. It doesn't matter. As long as you're careful with your math. And plug in y as 2. Negative 4x plus 5 times 2 equals 22. Negative 4x plus 10 equals 22. Take a 10 off each side. Negative 4x equals 12. Divide by negative 4, and x will equal negative 3. The ordered pair that is a solution to this system of equations is negative 3, positive 2. A reminder, from earlier assignments, we discovered that some equations, some systems, don't have solutions because there are three cases when you graph. You could graph the two lines and they could be parallel, in which case they wouldn't intersect. There wouldn't be any ordered pairs in common. That'd be a no solution. You could graph them and they intersect in one point, in which case you get one solution because where they intersect is the ordered pair that makes both equations true. But you could graph the two lines and they could end up being the same line, the same exact line, in which case they intersect at every single point, and they're infinite solutions. Those are the three possibilities. Most of the time, we're going to end up with just one solution, but I want you to see what it looks like when you solve. Let's make a pair of opposites. The smallest number that 6 and 18 divide into is 18. The smallest number that 4 and 12 divide into is 12. So you can go either way. Let's do the y's for variety. This is positive 12. I'm going to make this negative 4 negative 12, which means I just need to multiply it by 3. 3 times negative 4 makes negative 12, the opposite of positive 12. I'll rewrite this top equation, multiply everything by 3. 18x minus 12y equals 3 times 20 is 60. Rewrite that bottom equation, negative 18x plus 12y equals negative 60, and look at that. You add, you get 0, you add, you get 0, so over here we have 0. You add, you get 0, 0 equals 0. That's true. This is a true statement. What that is a clue is that there are infinite answers. These are actually the same equation. There's no difference between the two equations. In fact, if I took this bottom equation and I divided it by negative 1, it'd been the same as the top equation. They're the same line. They're right on top of each other. They intersect at every point. They're infinite solutions. We use infinity, which in WAMAP is 2 lowercase o's. In question 11, again, you don't have a pair of opposites, and I'm going to have to change both equations. 2 and 3, the smallest number that 2 and 3 divide into is 6, so that could work. 6 and 9, the smallest number that 6 and 9 divide into is 18. Let's use the x's because they're smaller numbers. So the top one, I'm going to make positive 6. Negative 2 times something is positive 6, that'd be negative 3. So this is going to end up being positive 6. Now I want the bottom here to be negative 6. What do I multiply negative 3 by to make it negative 6? That would just be 2. Let's rewrite both equations. The top equation multiplied by negative 3 becomes 6x minus 18y equals negative 66. That's negative 3 times 22. Multiply the bottom equation by 2, negative 6x plus 18y equals 64. This becomes 0, this becomes 0, that's 0 equals, when I add here, I get negative 2. This is a false statement. That's a clue. This isn't like the last question where they're the same exact line. This is the case where the two lines actually are parallel if you graph them. The two lines would end up having the same slope, but a different intercept. So when you get that false statement, that is when there's no solution. No solution is the answer. In WAMAP, we put DNE for does not exist. There is no solution. Question 12 is a normal one. It has just one answer. It's another one where we have to multiply both equations. 2 and 5, the smallest number that 2 and 5 divide into is 10. 4 and 3, the smallest number that 4 and 3 divide into is 12. I've been doing x's all the time. I'm going to do y's for variety. I'm going to make the top one negative 12, which means I'm going to take 4 times 3. 3 times 4 makes negative 12 because it's negative 4. So this one's going to be negative 12. I want the bottom one to be positive 12. What do I multiply 3 by to make it positive 12? Well, that would be 4. So the top equation, I multiply everything by 3. The bottom equation, everything by 4. The top equation becomes 6x minus 12y equals negative 54. The bottom equation multiplied by 4 becomes 20x plus 12y equals negative 24. Always add everywhere. We add because we have opposites right here. Those two are eliminated. I get 26x equals negative 78. Divide both sides by 26. X will equal negative 3. Negative 78 divided by 26 is negative 3. Take one of those equations. I'm going to use the top one. 2x minus 4y equals negative 18. And plug in that 3 for x. 2 times negative 3 minus 4y equals negative 18. That's negative 6 minus 4y is negative 18. Get the y by itself. Add 6 to both sides. Negative 4y equals negative 12. Divide by negative 4, and y will equal 3. The ordered pair that is a solution to this system of equations is x is negative 3 and y is 3.